Today we're gonna look at worksheet 9A. First thing we're gonna do is we're gonna do 9A. It says estimate the area A using 4 rectangles of equal width delta x. And we know that y of x is equal to -8 times k, where k equals 2 times 2 over L, which is 4 squared, so over 16 times x minus 1, which equals, this becomes -1. We have -x times x minus 1. This would be the right-hand rule, because what I'm doing is I'm taking the right side of this rectangle. I want to find the area under this curve, this part of the parabola. For everything above the x-axis, between 0 and 4. I want to make rectangles. As you can see, these rectangles are too big and really are not going to give me a great estimate of the area, because I have all this additional and all this additional. I'm missing this, so maybe these make up for each other, and I'm not going to have anything here, so maybe they're going to make up for each other. It's going to be an estimate, but as you can see, parts of it are not going to be there and other parts are. This is called the right-hand rule, because what we're doing is we're making these rectangles. We're going to use the right side of the rectangle to find my values. And we also have a left-hand rule, and we also have a midpoint rule. I now have my equation, and if I want to find the area of one rectangle, I find first my delta x. And delta x is b minus a over the number of rectangles. So here we're going to have 4 rectangles. And when I say b minus a, I'm saying the beginning point is here, and the end point is here. That's the distance between the two values, b minus a, and I want to divide it into 4 equal parts. I can divide it into 8 equal parts, 10, 3. It doesn't really matter. The more you do, the more rectangles you use, the closer the estimate. And I think I went over that in the other video, so I'm not going to go over that again here. So we have 4 minus 0 over 4, which equals 1. So now we know that the width of each one of these rectangles is 1. And now if I know the height, I'll know the area of each rectangle. The height is going to be here, 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 and here. Those are the right sides of the rectangle. I could also use the left sides of the rectangle, and also I could use the midpoint of the rectangles. If I use the right side, what I'm going to do is I'm going to sum from I equals 1 to 4. Here, I'll use the equation that they're giving me. I is approximately. And then y of x sub I, well, this is y. X sub I, x sub 1, we can say is 1. X sub 2 is 2. X sub 3 is 3. And the last one, which would be x sub 4, is 4. Okay, because we know now they're each one, the distance of 1 apart. If I want to find the area, I want to multiply the height times the width, and that would give me the area of this rectangle. This is the height. This is the y value. This would be y of x1. This would be y of x2, and so on. That's giving me my height. And then the delta x is giving me my width. And I know delta x, I found it right here. It's 1 I don't have to do anything with it because I can take this outside of the summation notation, or I can multiply each thing by 1. It's not going to change anything. I'm going to leave it out. I want to add up y of x1 plus y of x2 plus y of x3 plus y of x4. And yes, the whole thing in reality is times delta x, but we already said that that's 1. Y of x1, well, we know our equation for y. It's right here. If I want to know what y of x1 is, I just plug 1 into this equation. So I would have -1 times -3 plus, and then x2 is -2 times -2 plus -3 times -1. x4, that's 4, so I would have -4 times 0. So obviously, that's why there's no fourth box. I think maybe I should erase all this so that you can kind of see what the original picture looked like. If we add these all up, we get 3 plus 4, 3 plus 4 plus 3, yeah, and that's 10. My estimate using 4 rectangles and the right-hand rule, because I'm looking at the right side of the graph, my answer would be 10. Now, just so I can show you, I'm going to do this again. I'm going to use, let's do the midpoint. I'm just going to do the exact same graph. I'm going to draw it down here so we can still see it again. And this was 4, 1, 2, 3. And you guys got the basic idea. This is 1, 2, 3. If I want to use the midpoint rule, I'm going to go to the middle of each one of these pieces. And I'm going to make boxes that go up from here. So there's one rectangle. Then I go up here. There's a second rectangle. Then I just follow it up to my graph. And then I go over and make it a rectangle. And again, I follow it up to my graph. And I make a rectangle. And now I have actually 4 boxes. Whereas it didn't look like I had 4 boxes before because the last one had a height of 0. There is a box here, but the height is 0. So if I want to use this, let's see what we get. I have the same equation. I want to sum A equals the sum from I equals 1 to 4 of y of x I delta x. Delta x is still 1 because I still have 4 boxes and I still have the same distance between them. So delta x doesn't change. Delta x still equals 1. But instead of using 1, 2, 3, and 4 like we did the last time, when we use this when we do this summation, we're going to do y of xi, but the first xi is at 1/2 plus y of 3/2 plus y of 5/2 plus y of 7/2. Usually it's easier for me to work with fractions than decimals. So y of 1/2, let's plug it into our original equation. See, y of x equals -x times x minus 4. See what happens. we get that the area is equal to, actually, let me say this, times delta x, but my delta x is still 1, so I'm gonna let go of it just because it's 1, but it still would be there. So my area is equal to minus 1/2 times 1/2 minus 4, so that's minus 3.5, which is minus 7/2, plus, and then it's negative 3/2 times 3/2 minus 4, so that's 1.5 minus, it's 2.5, so that's 5/2, negative 5/2, plus, and then we're going to the next point. This is, my first point is 1/2. This is 1 and 1/2, 2 and 1/2, 3 and 1/2. I have, the next one's going to be negative 5/2 times, and then we have 5/2. 5/2 is 2.5, minus 4 is minus 1.5, so that's minus 3/2, plus minus 7/2 times 1 minus 1/2. And let's see what we get. We get 7/4 plus 15/4 plus 15/4 plus 7/4. Okay, well, that makes sense. It's symmetric. So this would give me 30 and 14 is 44/4, which is equal to 11. If I did all my math right, then that's what I get. It's definitely a different answer than what I got when I used the right-hand rule. And I'm not going to do the left-hand rule, but what it would look like would be, and I have my parabola. So if I use the left-hand rule, I would start here. This would be 1, 2, 3, and 4. And my first box, because I'm already at the highest y, is going to be just a straight line. And then this is the left-hand side. So I go this way to here. And then I follow 2 up to the graph. And then I go out to 3. And then I follow 3 up to the graph. And I go out to 4. As you can see, it's still, now we again have only 3 boxes because the first rectangle has a 0 height. Let's answer part B. And I just want to show you how these are similar. What we're doing is we're taking this delta x, which was a width of 1, and we're saying now there's infinitely many boxes. If I have this graph and I have a rectangle that's got a width that's approaching 0, and I probably could even make this smaller. It's not going to be as small as a width of 0, but imagine if this was my rectangle. Really, it's just a straight up and down line, isn't it? And it's almost like I'm coloring them in. I'm not putting them next to each other the way they should be. There shouldn't be any spaces. If there were no spaces, I would literally be coloring this graph in, because all the values would be that close together, and I get an exact area under the curve, which is what an integral gives me. Here we're just taking the height times the width, which is why this d of x is very important, and a lot of people forget to put that in. But it is a very important part, because without it, we don't have an area, do we? We just have a height. So we found what it is. with two different estimates on A. Let's see what happens with B. I want to calculate the area, the integral from 0 to L, and our L is 4, of y of x, which is still negative x times x minus 4, neither one. Okay, and then dx. We don't have an actual, like, take the integral of one thing and take the integral of the other. So what we have to do to integrate this is actually turn it back into a polynomial in standard form. So we're going to say the integral from 0 to 4 of negative x squared plus 4x, and this whole thing is times dx. And I put the formula sheet up for the different integrals, but the only one we're going to use here is called the power rule. And it says that the integral of x to the n dx. And notice this variable is matching this variable. The integral is equal to x to the n plus 1 divided by n plus 1. The derivative and the integral are inverse functions of each other. If I were to take the derivative, let's just do it to show you. Plus, we always add a constant. If I want the derivative of x to the n plus 1 over n plus 1 plus c with respect to x, you may not know this, but you can look at your formula sheet. I take n plus 1 is a constant. I can just take that out of the fraction. And then I just want the derivative of x to the n plus 1. And if you look on your sheet, we just take the exponent, which is n plus 1, times x to the n plus 1 minus 1. So it would be x to the n. And the derivative of a constant is 0. This cancels with this, and I end up with the derivative of the integral is equal to the original function that I started with. I just kind of showed you how they're inverses of each other, and you'll get lots and lots more experience when you do actually take calculus. Now it's a matter of just using the power rule to integrate, and then we're going to plug in the values. The integral of negative x squared is negative x. N is 2, so it's 2 plus 1 over 2 plus 1. That would be the integral of that. Plus the integral from 0 to 4 of 4x dx, because I haven't integrated that 4x yet. I can say this is equal to, let's simplify this, minus x cubed over 3 plus, I can say this is equal 4 times the integral from 0 to 4 of x dx. That should be one of the rules that is on your rule sheet. And then that equals minus x to the third over 3 plus 4 times the integral of x to the first power. So it's x to the 1 plus 1, which is 2, over 1 plus 1, which is 2. And then always we add this c. It's called a definite integral because it has bounds. And when it has bounds, I can actually find a value. Because what I'm going to do is I'm going to plug in these numbers. I'm going to write it in this with this notation. And then what I'm going to do is I'm going to plug in the top value first. So I plug in 4 first. This is one of the fundamental theorems of calculus. I don't think I should go into it except to show you how it works. So we have negative 4 to the third power, which is 64, negative 64 thirds, plus 4 times 4 squared is 16 halves. Actually, probably should just cancel this, make it 2. Do that. Two plus some constant, which we don't know. And then I take this and I subtract, plugging in the second number. Notice if I plug in 0 here, I'm just going to get 0 because x is 0. Second term is going to be 0, and the third term is going to be a constant. So whenever I have a definite integral, I don't have to add that plus c, because as you can see here, c minus c goes away. You only have to add that c when it's an indefinite integral, which I don't get a value. I don't have bounds. I just have a function, and I would literally have to stop here because I wouldn't have any numbers to plug in. But I do have numbers. So we have minus 64 thirds plus, this is 32. 32 times 3 is 96 thirds. 32, yep, that's right. Which is equal to 32 thirds, which is equal to 10 2/3, which is approximately 10.66666. And notice we're in the middle of both of our estimates from the rectangles. I am a little closer to, I'm only a third off from the midpoint rule, and I'm 2/3 off from the right side rule. As you can see, the midpoint rule will get you closer. We also have like a trapezoid rule, but I don't even think we do that anymore in calculus, where you can just make a trapezoid and it gets even closer. It's definitely not that important.